My name is Kayla Ufer, and today I'm going to be covering geotechnics and the study of sinkholes. You may ask yourself, what are sinkholes? You see sinkholes all the time in the news and reports and articles, and they're typically just depressions in the ground where the ground collapses beneath itself. They can vary in many different sizes, from little divots that you may see in your backyard even, to the large ones you see on the news that are extremely destructive. Essentially, these disasters start from water eroding into the bedrock layer, which is the very bottom layer, the ground, and over time forming pockets underneath. Those pockets tend to grow, and so it can no longer support the top layers of soil. And from there, that causes the ground to collapse beneath itself. As you can see here in this GPR image, as I'm going to talk about a little bit later, the ground at the very bottom here where the red is an indicator of a pocket of soil that's just collapsed. And as you can see from the light green kind of caving downward, that's the topsoil that's collapsing in on itself. So as briefly mentioned earlier, sinkholes can form anywhere where there's karst ground. So karst ground is typically a network of fissures, fractures, and conduits, or like a cave-like network. This can even be seen in caverns and springs that just kind of stretch underneath ground. So anywhere where there's just pockets of ground in the limestone area. Typically, this covers about 30 to 40% of the United States. As you can see in this image, as talked about in the last slide, 30 to 40% is either a sinkhole hotspot, which is covered in the red, or it's got karst ground, which can be seen in the light blue, the light green, and the pink areas. So all of these are very prone to sinkholes forming. So next we're going to talk about sinkhole formation. Typically, the best way to describe it is sinkholes form from rainwater seepage into the limestone bedrock layer beneath the top soil layer. So as mentioned earlier, this rainwater is very acidic, and on a pH scale where typical drinking water is a 7, rainwater is typically a 5 or a 5.5, so a lot more acidic than regular water. Rainwater can corrode away at this bedrock over time, especially over the course of several years. And typically in areas with poor drainage is where it can speed up the process of a sinkhole forming. Next, we're going to be talking about methods for testing for sinkholes. There are 3 typical methods for testing for sinkholes: the ground penetrating radar, which is GPR, the standard penetration method, and the cone penetration method, which the SPT and the CPT were both mentioned in the textbook for geotechnics. So for ground penetrating radar, essentially it uses electromagnetic radar waves to locate any cavities that are found in the karst ground beneath. As you can see in the image, this is the image shown in the earlier slides. This typically is used to locate any cavities that are in the ground, and these cavities will show up in an imaging software to produce what the ground looks like beneath. The standard penetration method is a boring method used to test the nature of the ground and the soil. So typically you use a steel driving chute, a steel tube split, a coupling, and a drill rod to be able to test the sample and get the sample. Once this sample is collected, it's typically tested in a lab, and this is a good indicator of finding a sinkhole because it'll typically indicate how eroded away or corrosive or acidic the ground is from the rainwater seepage. Also, another good indicator is a blow count, which is the number of times the hammer will hit the sample into the ground. And generally, when there is a low blow count, that means that there's a lot more likelihood that there is a sinkhole than a higher blow count. The CPT method is a lot more thorough than the SPT method. It's very similar in concept, but it's a lot more thorough as it's able to investigate tip resistance, sleeve friction, and pore pressure, which are all also huge indicators of determining if there is a sinkhole present in the area. As you can see from these graphs, the one on the far left is an indicator of the SPT, while the two on the right are indicators of the data from the CPT. Finally, we're going to be covering filling sinkholes in the event that one does occur. So there are three typical types of sinkholes that can form: the solution sinkhole, cover subsidence sinkhole, and the cover collapse sinkhole, which, depending on which type of sinkhole, there's going to be different methods for filling these. As you can see in this image, there's 4 different types of sinkholes actually. The berry just being a subsidence one that just happens to be in like a lake or a creek or somewhere where there's a large pool of water. But typically the solution sinkhole is a lot more of a minor sinkhole where the collapse is typically rare, but also it's a very severe problem. In the event of a small sinkhole, such as a solution sinkhole, that can simply be filled with sediment. Typically, it's wise to investigate the area and make sure there's no further evidence of a collapse nearby or anything, but typically those can just be filled. For a larger sinkhole though, it's really important to investigate and make sure the cracks aren't spreading underneath and that any voids such as caves, caverns, anything like that is blocked off before filling any of the remaining cracks. Typically you can use polyurethane or cement to fill the cracks and that'll cover it. But in the event that a structure is built on it, typically more measures are going to be needed. Typically using reinforcing bars, support beams, slabs, either steel or cement, those are always good means for supporting the structure in the case of a sinkhole collapse. While sinkholes are hard to prevent, technology and surveying are improving to make it easier to help locate them, especially in karst areas. In order to prevent a collapse near structures specifically, it's recommended to do thorough investigative research, such as using the boring methods and GPR imaging to make sure that you're not building anywhere near a potential sinkhole threat. Additionally, proper drainage systems are recommended in order to prevent excessive rainwater seepage, especially while building areas with large impervious ratios. So this means essentially when you're building somewhere, if you're building with a large impervious ratio, you're going to have less ground for the rain to be able to seep in, and that means more of the rainwater is going to collect in a smaller pervious area, leading to a potential collapse. So it's highly recommended that stormwater systems are thought out.